now the next topic is Hahn clause. A Hahn clause is a CNF clause with exactly one positive literal. The positive literal is called the head. The negative literal is called the body. Prolong. So this is what in prolonged language head body one body two in English to prove that head body prove an implication if and then. So on clauses form the basic of forward chaining and backward chaining. Remember this is for proposition logic. Don't confuse with the first order logic. So there are two types of forward chaining and backward chaining. One is for proposition logic and one is for proposition logic. Reasoning with Horn clauses, forward chaining. For each new piece of data, generate all new facts until the desired fact is generated. Data directed reasoning. And to prove the goal, find clauses that contains the goal as it had its head and prove the body recursively. Backtrack when you choose the wrong clause and goal directed reasoning. This is goal driven, that is like data driven if you observe this one. Now this is what given, actually they will give this kind of knowledge bases like fire any rule whose premises are satisfied in the knowledge base, add its conclusion to the knowledge base until the query is fine. Now the first thing is these two are our facts because there is not having any antecedent and consequence. So A, B are true by default because they are single we are going to get. Now if you observe carefully, under graph, we are going to call this one as under graph. Multiple links joined by an arc indicate conjunction. Every link must be proved. Multiple links without any arc indicates disjunction. Any link can be proved. So it is nothing but conjunction. So mostly we are going to have everything here is conjunction only given in the given question. So if there is a disjunction, you can also frame up this one only, but this arc that will represent as a disjunction. Okay, sorry, this arc if you are going to have that is going to conjunction. If you are not having any arc, that will become a disjunction. Okay, now AB, first write down AB. So first thing I'll explain here. First write down AB. So why we are writing AB means because they are all the fact, right? First write down AB. After AB, you search for is there any combination of AB is going to result as anything. So if you are going to combine these two, A and B, and this arc represents what? Conjunction. So this is nothing but conjunction. That arc represents conjunction, conjunction. So that arc is nothing but conjunction. That conjunction is going to result as what? It is going to result as one proposition. What is that? L. So one we are going to get, this is L. So A and B we are going to combine and it is going to get as a L. Okay. Afterwards, what we are having, L is having. So is there any resultant that you are going to get by combining something else we are going to get? We have to check carefully. So if you see here, B and L, the combination of B and L, we cannot directly bring something new. Okay, with available only we are going to take C. First AB, from AB we are going to get A, L, sorry. After that B and L we are going to get M. Okay, it is clear, right? Okay. So after that, we'll check is there any combination. So here this arc represent conjunction. Now L and M, if you are going to combine L and M, we are going to get a P. Okay. So is there anything? Simply P can derive a just a Q. So that is what. So now if you check this one, the combination of A and P is also we are having. A and P. Okay. A and P, what it is going to derive? A and P, if you are going to combine, it is going to derive L. So that is what written like this reverse. Okay. If you are going to combine these two and it is going to derive. Our main intention was you have to prove this one. That is the main task. You have to prove P implies Q. We got P implies Q. This is a forward chaining. So one more kind of method we are having in our proposition logic, that is a backward chaining. You go through once this material, you'll understand. So now forward chaining has been completed. Now coming to backward chaining. So what happens in the backward chaining? We are going to take the goal. What is our goal? Q. So we are going to take Q. By taking Q, we are going to check is there any kind of RHS, sorry, LHS part is left over. So see here. Okay. So here we are having P implies Q. So what Q now we are going to, where we are going to get Q means from from P, right? So from P we are going to get. So we will write like this. Now, is there anything left over for this uh, whatever that result we want to get? Is there any leftover? So PQ is done. Is that anything we are going to get or we can get? If you observe carefully over here, so P we are having. After P, the combination we are going to get from L and M. L and M is resultant of P. So that is a disjunction. So we are going to get. So where P is derived means from the L and M. So we are going to derive P. So next one, where L is going to derive means from A and B. We are going to write like this. And from A and B also we are going to get M. So like that you'll repeat and at last we are going to get. So after getting all this one, here in this one we have to prove these are true. Why? Because these elements, if you are going to get single, they are obviously true. So this AB is true, automatically L will become true, automatically M will become true. So everything will become true. So this is how our backward chaining works.